Hi, I'm Israel, and today we're going to talk about gravitational waves. Yes, you heard right, gravitational waves. Are you familiar with gravity?
Yeah.
How about waves?
Yes.
Okay, I want to pass you over to Professor Claudius. Gravitational waves are invisible ripples in the fabric of spacetime that propagate as waves at the speed of light. These waves are generated by certain gravitational interactions and move outward from the source. As they move outward, they stretch and compress any object in its path. Let's imagine a tight fabric. Now, let's place a baseball in the middle. What would happen? The baseball will bend the fabric, and any other object of smaller mass will move towards the baseball. This analogy is exactly what happens in our universe. In fact, with any object with mass, will cause this bending, or how we like to say, a curvature in spacetime. It was Albert Einstein, in his general theory of relativity, that explains gravity as a distortion of space. Sometimes, a massive object can lens the light of a star and give the illusion to an observer that there are two stars. Astronomers first thought that these stars acted like twins because they had the same luminosity, diameter, and rotation, but the truth is that there is only one star. Let's get crazy. Imagine a massive object being ripped away. Even better, imagine if a Type 3 civilization came to our solar system and snatched our sun away. What would happen? Would the Earth be put into immediate darkness and fly out into space? What did you say? You forgot that both gravity and light have a set speed, which we call the speed of light. When the sun disappeared, space oscillated itself back in a state of equilibrium, and that state of equilibrium expanded at the speed of light. It's still there! Of course the sun is still visible. The last photons emitted from the surface of the sun takes an average of 8 minutes to reach the Earth. It will take 8 minutes for the space around the Earth to return to a state of equilibrium, and then the Earth will drift off into space. Now, let's get to the real deal. Gravitational waves are generated when massive objects move quickly through space. Best known examples are when two black holes revolve around each other until they collide. And just like Professor Claudius said, they move outward from the source, just like a water ripple. Scientists can detect gravitational waves through the use of LIGO. LIGO is the Laser Interferometer Gravitational Wave Observatory. In simplest manner, LIGO uses two perpendicular vacuum tunnels that are an equal length of 4 kilometers. A laser is shot and split. The laser travels down the tunnel and bounces off the mirror. The light waves travel back down to the tunnel and into a photodetector. This photodetector looks to see if there are an interference pattern. So what? What is fascinating about these gravitational waves is that it is a new method to see further into the universe than we have ever been able to see before, letting us reach further back in space and time. It allows us to know what is going on in black holes, and hopefully it would also help us understand dark matter and dark energy. And one day, we will be able to detect the gravitational waves from the Big Bang itself.